Welcome to clickmyproject.com. We discuss about Lattice code for the Gaussian relay channel, decoder and forward, and compress and forward. Lattice codes are known to achieve the capacity in the Gaussian point-to-point channel, achieving the same rate. Random Gaussian code books. Lattice codes are also known to perform random codes for certain channel modes that are able to exploit the linearity. In this paper, we shows that the lattice code may be used to achieve the same performance as no Gaussian random coding technique for the Gaussian relay channels, and shows the several samples of the how this may be combined with the linearity of lattice codes in multiple source relay network. In particular, we present a nested lattice list decoding technique in which lattice codes are shows to achieve the decoder and forward technique rate of single source signal destination Gaussian relay channel with one or more relays. We next present two examples of how these DF schemes may be combined with the linearity of lattice code to achieve new rate regions which for some channel conditions output performs along known Gaussian random coding technique. In multi-source relay channels, that is, we derived a new achievable rate recognition for the two relay channels with direct link and compare it to existing schemes. Derive a new achieve rate of region for the multiple access relay channels. The transmit to the improve the communication performance. The 0 in 1s are transferring the lattice encoding performance. The lattice encoding performance will be shown. The lattice encoding is a relatively complex evaluation. X equal to g of I is 1 of squared, as g is not sparse. Nevertheless, efficient encoding can be done by solving effectively, say by Jacobian method, the sparse linear equation h of x equal to I. Further simplification by incorporating encoding with shaping. The compress and forward technique, it is that the lattice output is given into compress forward technique. It is the data will be compressing and forward to the relay channel. The relaying mode receiving the compressed output. The relay fading model is particularly useful in these scenarios where the signal may be considered to be scattered between the transmitter and receiver. The relay propagation model is most applicable to instances where there are many different signal paths, none of which is dominant. In this way, all the signal paths will vary and can have impact on the overall signal at the receiver. The output is given into decoder and forward technique. The decoder and forward schemes and iterative schemes for calculating the PDF f of x, y, k equal to 1, n, message passing between the variable nodes, and check the nodes messages or PDF estimates. The check node constraint summation of h of I equal to x of k of I equal to integer leads to convolution steps. The variable node constraints get estimate of the consider variable PDF form. The check the nodes and the observation leads to product steps. LD, LZ and lattice code is general are used at high SNR where the factors of bits divided by seconds calculated is high. The lattice decoding output is given into result analyze method. It is using for analyzing the performance, how that the communications will be transferring the informations is better than result. The output is shown. This is for output performance of encoding and decoding lattice encoder output. First we selected for cm.m and right click to run the file. The output will be performance. The for command window first we see output, then the graph will be shown for output. First we the lattice code n equal to 2, k equal to 3 and the code memory equal to 3 will be initialized. Block code length, it can be determined for output code of modulate symbols. It can be represented by 5112. Input data symbols, it can be represented for 512. EB, NR, DB and BER rate will be calculated. The calculated rate first can be shown for that 4.5 region of the output. The process will be run. Please wait. It is a representation of the input of the bits, and the data transmission will be considered for 0 to 1200 channels allocation. The timing allocation of the bits will be amplitude will be calculated. Output will be shown. It is represented of the encode of the bits of the each streaming of the values will be calculated amplitude and timing representation value. The output will be shown. The relay channel will be each channel will be allocation of 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. The channel level can be difference level and amplitude level also difference. It can be calculating with the relay channel hope. The hope will be calculated, output will be shown. It is representation into the decoder output. The decoder output performance will be shown. The decoder output, the transmitting the encoding bits also will be retrieving from the decoder. The decoder of the binary bits of the informations will be received. The output will be calculating will be shown for the figures. Will be receiving for efficient manners. In this performance, we will be discussing the lattice performance of the encoding and decoding performance. Will be the transferring the information will be efficient manner. Thank you.